Hi, today we are going to talk about binary classification from positive confidence data. If you think about the ordinary binary classification setup, you learn a binary classifier with both positive and negative training data. However, in the real world, sometimes you can collect positive data, but you cannot collect any negative data. So here's a research question. Can we learn a binary classifier from only positive data? So this means we do not have any negative data, or even unlabeled data, and this seems like a very difficult task. If you really only have positive data, you would not have any information of the negative distribution. For example, you would not know the direction of the negative distribution compared to the positive distribution, as you can see from the upper figure. You might be thinking about one-class classification or anomaly detection methods. These describe the positive class by, for example, clustering-related methods, as you can see from the lower figure. But they do not have the ability to tune hyperparameters for maximizing the generalization ability, and their aim is not on discriminating positive and negative classes. So one-class methods are quite different from binary classification, which is what we want to do. So what should we do? Here's our main idea. Even if we only have positive data, for each of those samples, sometimes we can attach a confidence score. For example, if you're trying to solve a dog versus wolf binary classification problem, you'd only have dog images, but for each of your dogs, you can attach a confidence score. For example, 95% dog. If you look at the figure on the right, the darker colored ones show high confidence, and the lighter colored ones show the samples with low confidence. In this kind of situation, I think you can imagine that the classification boundary would be somewhere in the lower right-hand side, as you can see with the black line. This is somehow intuitive, but does this really work? Can we really learn a good binary classifier? So the main message of the paper is that if you can equip your positive data with this kind of confidence, which we call positive confidence, you can actually learn a binary classifier with optimal convergence rate. This was previously impossible when you only had hard-labeled positive samples, but now we have the additional positive confidence scores, which include the information of the negative distribution, and this allows us to discriminate between the positive and negative classes. In the paper, we call this positive confidence classification or PConf classification. So the goal of binary classification is to train a binary classifier G so that the classification risk R is minimized, where R is defined with the expectation over the joint distribution Pxy. But this is problematic because we don't have data from the joint distribution. We only have positive data from the positive distribution. In the paper, however, we show that we can express the risk with only positive confidence data, which means we do not need any negative data or unlabeled data, and we can learn a binary classifier from only positive confidence data. So if you're interested, you can read our paper or you can come see us in our spotlight talk or our poster time. Thank you for watching.